All right, guys, today is day 14, and we're looking at two lessons today. So we're doing 55 and 56. So nets of prisms, cylinders, and cones. There's a good video that goes along with this, and some of you guys are better at drawing these two-dimensional prisms and nets than I am. But again, all a net is we could think of like a three-dimensional shape as a box, and if we laid it out flat two-dimensionally, what would it look like? And so a pyramid would look like this. We'd have 1, 2, 3, 4 triangles, 1, 2, 3, 4, and a square base. So that's what the net for this pyramid would look like. It kind of helps us when we're thinking about surface area or lateral surface area to have our nets, but again, we have our formulas, but these nets, and we'll watch a video that goes over them and how they can kind of be visualized. So I'm not very good at drawing them, especially on the on this whiteboard. So I'm not going to attempt to do all of them, but we will work through them. So if we sketch this net into a triangular prism, it's a triangle top and bottom. So there's our two triangles. I have 1, 2, 3 rectangular sides or faces. So there's my 1, 2, 3 rectangles. Now finding the surface area or lateral surface area, I just got to find the area of these two-dimensional shapes and then add them up. Okay, if we're sketching views of this, different, then draw the net. Okay, well, again, if we think about a box, we'd have front and back, and those would be the same rectangles. Left and right would be congruent, and then top and bottom. So no matter which way you think of a box, okay, your top and bottom match, your left and right sides, and then your front and back always match up. Cone is going to be a little bit different. It looks like a sweep, as we call it. So you can imagine if you had like a wrapper for an ice cream cone or something and you laid it out, it would kind of have a unique shape to it. It wouldn't be a rectangle. It wouldn't be a triangle. It would be something like this where it's got two straight sides and then part of a circle, like an arc right here. So we'll work with how you can find those formula-wise down the road. All right, that is our lesson for that. And the second one is lesson 56, which is slope-intercept of an equation. So slope-intercept, we're using the y equals mx plus b form. So m is what we call the slope in our formula, rise over run for slope. And then plus b, y equals mx plus b, whatever this value is our y-intercept, or where it crosses the y-axis. Sometimes we don't have anything in there like y equals 5x. Well, there is no plus or minus any number. So that means it goes through the origin. So if there is no y-intercept or no plus or minus out here, that means that it goes through the origin. And we would find that when we graphed it as well. So y equals mx plus b form. You've heard me talk about that. This is known as the slope-intercept equation or formula. So m is our slope, b is our y-intercept. So again, if we look at some of these, y-intercept is the origin. Rise over run, 1 over 1. So the slope is 1. So y equals 1x or y equals x. Okay. Y equals 2x. Y equals x plus 2. So we go up 1, 2, because there's my y-intercept. So it's up at the point 0, 2. So where x is 0, y is 2. Well, that makes sense because 0 plus 2 is 2. And so that's my y-intercept. Okay, we can have negative slopes. It can be less than 1, greater than 1. We can have horizontal lines. Vertical lines are undefined, which means they don't pass the vertical line test. They're not technically functions. Yeah, we could still draw it here, but we have one input giving us infinite amounts of outputs, which means that it is not a function. Okay, so if we're looking at y equals 2/3 x minus 4. Okay, well, 2/3 is our slope minus 4 is the y-intercept. So we'd go down to -4. That would be a point. And we could put in 1 for x, 2, or whatever, calculate it out to find another point, or we could use the slope, okay, to start from -4, a rise of 2, run of 3, 2 over 3, to find any point, and then that would be our line. Okay, if we're looking at these, we're writing let's look at A and B lines. Okay, so A goes through -2, so that would be my y-intercept. Let's do rise over run, 1, 2, run of 1, so 2 over 1, so the slope of 2. So y equals 2x minus 2. B is at, the y-intercept is at 1, okay, so it'd be plus 1. Slope is rise of 1, run of 2, so 1 over 2, so 1/2 x plus 1. We have those two based on our rise over run, and then our y-intercepts. We can write these in slope-intercept form. Okay, I'll show you guys how we could graph these by hand. Is we'll put in the point -3, our y-intercept, just like we always start with the origin. Or if it doesn't go through the origin, we'll start with the y-intercept. So just go down 3, and then we have a rise of 2 over 1, so up 2 over 1. There's our next point. You have 2 points. You can connect the dots, and you have your line. I'll also show you how we can do this in our y equals. You may remember how to do it, but I'll show you in class how we can graph these in our calculator to make life a little bit easier. Again, it's still going to show us what we need to, but it's sometimes if we're looking for a specific point or value, we can do it by hand and with a formula, but we can also use the calculator to help us. Okay, practice set we will go over as a class. Okay, so that is it for today.